Hello everyone, my name is Shekhar Malik and I am from 2CSCD of the roll number 5K6. Today I am going to discuss a seminar in the topic in the subject computer organizations of the topic internal organization of the processor. Let me get started. So this is the outline of the internal organization of the processor. This is the bus and these are all the parts, registers, special registers, ALU and etc. that takes place. Let me give, let me first uh, present you the parts and we'll later discuss about the usage and functionality of these. The first one is ALU here, and these are the registers for temporary storage from R0 to Rn minus 1. Various digital circuits for executing different micro operations, marks, decoders, counters, etc. Internal path, the movement of data between ALU and registers. Driver circuits for transmitting signals into external units. Receiver units for incoming signals from external units. So let us get started with the usage and functionality of these one. PC stands for program counter. So the functionality is it keeps track of execution of program and it contains the memory address of the next instruction to be fetched and executed. So let us think as an instruction is being executed right now. So PC stores keeps the track of the instruction. At the same time, it also stores which instruction is going to be decoded in the next after this one. The next one is MAR. It stands for Memory Address Register. It holds the address of the location to be accessed. So let us say we need a value of a variable or something. It stores the location of the variable in the memory. So and the input of MA is connected to internal bus and the output is connected to external bus. The next one is MDR. MDR stands for Memory Data Register. It contains the data which the MAR address holds. If let's say MAR address holds the data of a variable, so what MDR does it after it sends the address, it takes the value from that address. It contains the data to be written into a readout to the address location. It has two inputs and two outputs. MDR. Data can be loaded into MDR either from memory bus from internal process bus. The data and address lines are connected to the internal bus via MDR and MAR. This is the functionality of memory data register. The next one is register. General purpose registers are R0 to Rn-1, which are located at the in the processor. The processor registers R0 to Rn-1 vary considerably from one processor to another. Registers are provided for general purpose used by programmer. Special purpose registers, index and stack registers. Registers Y, Z and temp Y, Z and temp registers, temporary registers used by processor during the execution of some instruction. And then multiplexer. Multiplexer, what it does is takes the output of Y or a constant value to be provided as the input to the arithmetic and logical unit. This is the multiplexer. It takes the output of Y and constant 4 and selects A as the input, which to be given to the ALU. Constant 4 is used by processor to increment the contents of PC. Constant 4 is used by the processor to increment the contents of PC. The next one is ALU. ALU stands for arithmetic and logical unit. So it is used to perform arithmetic and logical operations. Data path. The registers ALU are interconnecting bus are collectively referred as data paths. Register transfers. So how register transfers work? Here, the input is taken, output is sent to the bus. So every register works in the same way. And in this multiplexer, the output of Y is sent to here on constant 4 is set to increment the instructions of the PC and it is sent to A. And in this, the operation is performed on A and B arithmetic operations and output is sent to Z and the Z will put the output onto the bus. This is how it works. If we take the instruction R3, R1, R2, what happens is the data of R1 and R2, uh, R1, R2, and R3 both are added and stored in R3. So R1, R2, and R3 here. So both the data of these three will be added and stored in R3. And these are different functionalities of all the registers here. MDR, fetching a word from memory, storing a word in memory, executing complete instruction, control sequence, branch instruction, etc. All the functionalities of these registers, which we discussed up until now. This is the fundamental concepts of the processor. Thank you, everyone.